Hey guys, Professor Schupak here, back today with another video. In this video, we're going to go over critical fractile analysis and we're going to derive how do we calculate the critical fractile ratio. So what is critical fractile analysis? So critical fractile analysis is the cost of being understocked and the total cost of being either understocked or overstocked. We'll get more into that. So let's use a problem to help us better explain this. Let's say that we're a newspaper vendor and we buy newspapers for 35 cents each and we're selling them for 45 cents each. If we don't sell them by the end of the day, then we have to return them and receive a credit of 5 cents per newspaper. We also, because we're buying them, we don't know the demand we're going to need. Well, we know by historical data that the demand for 20 newspapers is 10%, 21 is 15%, and etc. as shown in the table at the bottom right. Now, the first two things we need to figure out are what are our gains and what are our losses. So gains are whatever we earn, and losses are whatever we lost in the process of trying to gain something. So gains, well, we bought newspapers for 35 cents, and we sold them for 45 cents. So the gain would be 45 cents minus 35 cents, which is 10 cents. We made 10 cents for every newspaper we sold. Our losses would be the newspapers we didn't sell. So if we didn't sell a newspaper, that would be 35 cents, but we did get 5 cent credit back. So it's going to be 35 cent minus 5, and that's 30. So gain is 0.1, losses is 0.3. Moving forward, 21 is equal to 20 plus 1. You'll see where that comes in later. And let's talk about this for a second. So we're gaining 10 cents for every newspaper we sell and losing 30 cents for when we don't sell. So if we buy 20 newspapers and there's a demand for 20, then we're going to make 10 cents by selling all 20 of our newspapers. But if we bought 21 newspapers, well, we're going to sell the first 20 and make 10 cents on each of them. But that 21st newspaper, because it wasn't needed, we're going to lose the 30 cents on that. So the expected value of 20 newspapers when the demand is 20 is going to be 20 times 0.10 because we're selling every single one and we're getting 10 cents. But the expected value of 21 newspapers, if the demand is 20, is going to be that 20 newspapers that we sell minus the 30 cents for the additional newspaper that we have. So E of 20 is going to be 20 times 0.1 like we said. And E of 21 is going to be that 10% probability from the table that we're selling 20 newspapers. And if we bought 21 and the demand was 20, again, that would be 20 times 0.1 minus 0.3, plus the alternative probability. So we have the probability that the demand is 20. The probability of demand being greater than or equal to 21 would be 1 minus that probability. So 1 minus 0.1 is 0.9. And then we have, if there are 21 newspapers in demand and we bought 21, that's 21 times 0.01. From this, we could take that 0.9 times 21 times 0.10, and we could rewrite the 21 as 20 plus 1, as we mentioned earlier. So the 0.9 times 21 times 0.1 is going to be 0.9 times 20 plus 1, or 21, times 0.1. And when we multiply that out, we get 0.9 times 20 times 0.1 plus 0.9 times 1 times 0.01. Moving forward from this, that 20 plus 1 times 0.1 is the same as E of 20 as we see in the top left, 20 times 0.1. So we have an E of 20 times 0.01. So we have 0.9 times expected value of 20 plus 0.9 times 1 times 0.01, the second half of that equation. Which means, after all of this, what we just figured out is that the expected value of 21 will become the 10% probability of the expected value of 20 minus the 30 cents we lose for that additional newspaper, plus the 0.9 times the expected of 20, plus the 0.9 times the 1 times the 0.1. So let's see, what do we have here in this formula? We have the 0.1 at the beginning. Well, that's the probability that demand is 20. And then that 0.3 in parentheses from expected value of 20 minus 0.3, well, that's our loss. If we don't sell a newspaper, we're losing that. And then the 0.9 on the other side is, well, we have the probability of 0.1 being demand equals 20. So the alternative demand, anything else, is 1 minus that. So 1 minus 0.1 is 0.09. That's the probability that demand is greater than or equal to 21. That's the only other option. And the 0.1 at the end, well, that's our gain because we're making 10 cents for every newspaper we sell. So that's our gain. So if we take this formula and we plug in the 0.1 for probability, the 0.3 for the loss, and we substitute all these words in, we get that E of Q plus 1 is equal to the frequency distribution of Q times E of Q minus L for loss plus 1 minus the frequency distribution times Q times E of Q plus 1 minus the frequency distribution of Q times G, our gain. Moving forward from this, if we multiply this all out and we cross out like terms, this is going to simplify to become E of Q plus 1 equals E of Q plus G minus the frequency distribution of Q times G plus L. which in our scenario, we're selling, right? We're sellers. We want to make the most money. Why would you want to make less if you're trying to make money? So that means that we want to keep buying units as long as an additional unit makes us more money. For example, if I can make more money buying 11 than I will with 10, then it makes sense to get 11 rather than 10. If I can make more money with 12 than 11, I'll buy 12. But if buying 13 units does not give me more money than buying 12, that means I'm going to be losing money. So I might as well stay with 12. So as long as adding an additional inventory makes more money than the previous, we do it. So that satisfies the condition that E of Q plus 1 has to be less than or equal to E of Q. Moving from that, that means that E of Q plus 1 minus E of Q has to be less than or equal to 0. But we said that the E of Q plus 1 minus E of Q above, we said that that is actually equal to the gains minus the frequency distribution of Q times the gain plus losses. So the gains minus the frequency distribution of Q times the gains plus losses has to be less than or equal to 0. So if we take that inequality and we solve for the frequency distribution of Q, we arrive at our critical fractile ratio, which is that the frequency distribution of Q has to be greater than or equal to gains over gains plus losses. That is how we derive the critical fractile ratio. To use an example and see how this ratio can help us make decisions for a business and solve problems, we will cover this in the next video. Thank you guys for watching. That's the critical fractile ratio. I hope you enjoyed it. If you like this video, please like, comment, subscribe, and share it with a friend that you think might need it. See you guys in the next video.